A capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends. If the length of the entire capsule is 12 millimeter and the diameter of the capsule is 3 millimeter, how much medicine it can hold? So this is the question. Okay, so this is an interesting question where we are going to have a combined figure. What type of combined figure? We are going to have a cylinder and the hemispheres together. So just imagine the rough image of the given capsule. If this is going to be the cylinder, right? Fine. So this is our cylinder. Now what are we actually saying? To this cylinder, okay, to the top and bottom, we are having hemispheres like this. Right? So imagine if this is going to be the capsule which we are talking about. Okay? So a capsule is in the shape of a cylinder with two hemispheres stuck to each ends. Okay. If the length of the entire capsule is 12 millimeter, length of the entire capsule from the top to the bottom, the entire height, it is 12 millimeter. Okay, and the diameter of the capsule is 3 millimeter. What is meant by diameter? This distance. Okay, so this distance, it is 3 millimeter. Okay, how much medicine it can hold? So this is the question. Okay, so now we are going to identify the volume of the capsule, by which we will be able to identify the capacity of the capsule. Okay, so whenever we are discussing about the combined figures, we will be identifying the areas separately. Same way, when we are talking about the volume, again we are going to identify the volume of the cylinder separately and volume of the hemisphere separately, for which we need to know the dimensions of the cylinder and the dimensions of the hemispheres as well. So first thing, let's discuss about the dimensions of the cylinder first. So first we are talking about the cylinder. Volume of the cylinder, the formula is what? Pi r square h. So we need to know the radius of the cylinder and we need to know the height of the cylinder, right? So now first let's finalize the radius. So the radius of the cylinder r, it will be, the diameter is 3 millimeter in the sense. How about the radius, children? It will be diameter by 2. So the radius is going to be diameter by 2, that is 3 by 2 millimeter. This is going to be the radius of the cylinder. Next, we are going to talk about the height of the cylinder. Okay, so now when we are talking about the height of the cylinder, we are given 12 millimeter. What is this 12 millimeter actually? This is the height of the entire capsule. Where is the cylinder? From here till here, this is the cylinder. So this will be the height of the cylinder as well, yes or no? So now we are going to discuss about the height of the cylinder. Okay, we are having hemispheres, right? So these hemispheres are stuck to the top and bottom of the cylinder, yes or no? So now just remove the diameter of the hemispheres in the top and the bottom. This distance 3 millimeter, remove it. This distance again 3 millimeter, remove it. Why that distance is 3 millimeter? Because if we are talking about the diameter this way, it is 3 millimeter in the sense, then the diameter this way also it will be 3 millimeter only, right? So that 3 millimeter we are removing it, so that we will be able to identify the height of the cylinder alone. So 12 minus 3 minus 3, 12 minus 6. 6 millimeter, this is going to be the height of the cylinder. I repeat once again, listen carefully. We are having the hemispheres in the top and the bottom. We are told that the radius, that is the diameter of the capsule, is 3 millimeter. So if we are talking horizontally, if the diameter is 3 millimeter, vertically also the diameter will be 3 millimeter. So just remove that hemispherical diameters in the top and the bottom. So that remaining distance, this will be the cylinder, and that's nothing but 6 millimeter. Okay, so this is nothing but the height of the cylinder. Now let's talk about the hemisphere. Okay. Now for the hemisphere, what's the volume formula? 2 by 3 pi r cube. So we need to talk about the radius alone. So what will be the radius of the hemisphere? It is going to be 3 by 2 millimeter. That's it. Okay. So we are done with the dimensions of the cylinder and the hemisphere now. Now let's enter into the formula where we are going to identify the volume of the capsule. Volume of the capsule will be equal to the volume of the cylinder plus the volume of the top hemisphere and the volume of the bottom hemisphere. Both the hemispheres are equal. So we are having two equal hemispheres. So volume of the cylinder plus 2 times volume of the hemisphere. That is volume of two equal hemispheres. Right? Now let's write down the formula. Volume of the cylinder. What will be the formula? That is pi r square h plus 2 into volume of the hemisphere. What's the formula? 2 by 3 pi r cube. Why are we having 2 into here? Because we are having two equal hemispheres. Volume of both the hemispheres, we are going to take it into count now. That is why 2 into volume of the hemisphere. Okay, now let's try to take the common terms outside so that it will be easy for calculation. Pi is common, let's remove it out. R square is common, here we are having r cube. So let's take r square outside. So pi r square, we are removing it out. So what's pending in this term if we are going to remove pi r square? H is pending. Let's have h plus 2 into 2, 4, 4 by 3. We are removing pi outside. Then 3 r terms are there. R cube in the sense we are having 3 r's in which 2 r's we are taken out. R square in the sense r multiplied 2 times. So 2 of the r terms we are removing it out. So how much r's are pending? One more r is pending. So that's why 4 by 3 r. Okay. So this is how you take the common terms outside. Now let's substitute. 22 by 7 into r square. What is r? 3 by 2. So 3 by 2 the whole square. So 3 by 2 into 3 by 2. Right. Into h. What is h? H is going to be the height of the cylinder here. So that is 6 millimeter. So 6 plus 4 by 3 into what is r? R is again 3 by 2. So 3 by 2. See, here we are having the combined figure for a capsule. That is why the radius is common for the cylinder and the hemisphere. That is why we are considering everything together and we are taking the common terms outside. But this may not be possible for all the cases because the radius might not be same when we are talking about some other combined figures. Okay, so we need to be very careful in those cases. For this problem, it is possible for us to take the common factors outside. Okay, now let's try to simplify. 2 times 4, 3 and 3 gets cancelled. Here 2, 11 times 22. That's it. So this is 11 into 3 into 3, 9 by 7 into 2, 14 into 6 plus 2, 8. Okay, now let's try to cancel again by using the two tables. 2 4 times 8, 2 7s are 14. So this is 44 into 9 by 7. Let's find out what is 44 into 9. 396. So this is 396 divided by 7. Let's find out what is 396 divided by 7. I'm going to do the division here. So 396 divided by 7. 7 5 times 35. Balance 4. Bring 6 down. 7 6 42. Balance 4. Decimal point 0. 7 5 times 35. Balance 5. 0. 7 6 times 42 again. So it goes on. Let's stop with this. It is 56.56 millimeter cube. So this is going to be the capacity of the capsule. That is, this much of medicine can be put inside the capsule. That's it. Hope you all understood. Thank you.